Hi folks, welcome to Module 3. Also welcome to the last week of class. What a unique semester. Week 15, we're finally here, so we either celebrate and say hooray, or we say, oh my gosh, I can't believe we're here already. But what I wanted to do was, in this last presentation, I wanted to sort of bring all these things together and integrate all the things we've talked about. One of the things we do in ISBIT, our first name is integration. So let me push this button here. So yeah, I've titled this presentation Putting It All Together. I want to talk about some of the aspects that we've covered this semester to see why we talked about these individual parts and how we integrate them together and put them in the system. So this is stuff that we've been talking about all semester, especially since our most previous modules here online, chapter 1 and chapter 2. So this next slide looks blank because I guess it is, but as we know, it's not really blank. If it was blank, the whole box would be black. It's actually a giant white box, and it contains a lot of light. You can see the white is reflecting off my face. My big white Santa beard is all white. There's a lot of stuff coming out of this white box. So in systems thinking, a white box represents a lot of things, not nothing. And it's difficult to talk about many things or an infinite number of things at the same time. So we have to sort of figure out what we're talking about and what we're not talking about. So of course, since day one, we've been drawing the box. And again, the box is a set of training wheels. It's something that helps us get to discuss things. The box does not have to be real. Many times it is, but it doesn't have to be real. It can be a conceptual box, but we're going to start with that. So here's our box. We're going to go ahead and draw. I've drawn it as a square or a rectangle. And one of the things that we know, once we have the box, we can say that things that are inside the box are the stuff we're concerned with, and things that are outside the box are things that we're not necessarily concerned with. Maybe we can't change them or control it. Maybe we can influence it. But we have inside and we have outside now that we've drawn this boundary. So of course we use this term, the environment. The environment just means that which surrounds the box. We have the normal environment that people talk about, sort of like environmental science. So we often talk about the environment being outside, where we get that phrase, outside the box. If the box happens to be a house, then the environment is outside the house. If the box happens to be a city, then we talk about it being outside the city. In this case, we have the box, we have the environment, we have its walls of the box, if you will. We also know that whatever goes on inside this box, if this box is to do something or if it is to have purpose, then what happens is the box does what it does, and then it takes whatever it produces and it puts it outside the box back into the environment. So of course we talk about it putting something that it used out, so it's output or something to put out that we've talked about day one. This output can be something that's desirable. It makes something intricate and beneficial. We talked about Henry Ford. Maybe this box is making cars. Or it could be a waste product. I'm not sure. Maybe this box is a tree, and the waste product of tree is oxygen. That's a pretty good output for our concern. After a while, the box runs out of materials on the inside. It sort of eats up or consumes its stock or its inventory of supplies. So it's going to need a new supply no matter what we're talking about. Biological cells, a business. We talked about the beer game. Sometime we're going to need to restock. And when we restock, of course, we're going to restock that with input. And the input's going to come from the environment into the box. I know I'm belaboring this crazy, but we just make sure that this is our fundamental things that we've been talking about this semester, and I want to sum everything up. Our last piece, of course, is once the input is given into the box has to know or be good at or expert at assembling the inputs into something and then producing the output. So, of course, we have to have instructions inside the box, and those instructions are, of course, called the process. How are we going to go ahead and put these things together? So here's our big integration of everything. We have a box. The box produces something, and it produces something by taking supplies on input, following a process, and then returning it to the environment. We know that the output doesn't have to be one single thing. It can be many things. I've only have room for 3 hours here, and everyone knows that I like the number 3. It could be 1, it could be 0 if the system is closed, like CVS is closed for whatever reason, or it could be something that's difficult to count, like hundreds of thousands, or perhaps it's an explosion, or maybe we're talking about the particles that our sun in the middle of our solar system emits per second. That's a lot of particles coming off of our huge monster sun. So we could draw as many arrows as we need, but that's what we have here. And we know, because we've talked about it, the reason why I've chosen 3 is we can summarize or group the inputs and group the outputs into 3 major or primary categories. And those 3 major categories are, not a spoiler, not a foreshadowing, we talked about it, energy, material, and information. And those of you who are upperclassmen ISBIT majors who have taken some of the future classes, you know that we have an entire class that pretty much concentrates on energy. That's ISBIT 112. We have a class that concentrates on material, which is ISBIT 212, and we have a class that concentrates on information, which is ISBIT 211. They're all sort of taught in different orders, but that's why they were created. So we have the system itself, and then we have an individual course that talks about energy by itself, material by itself, and information by itself, because it's important. And I've let the cat out of the bag. Instead of calling this a box, there's the box. But now that we have the box and the process inside, and the inputs and the outputs and the environment, this entire thing together, of course, is called a system. So this is what we've been studying all semester. We have the system, which is fantastic. Of course, once we get the system, that's great, wonderful. But what really happens is we sort of say, well, let's be advanced about this. We're going to look at a system of systems. So we're going to take the individual systems, and the output of one system, look over here, the output of one system can be the input of another system. And it depends on how you want to talk about these. I just happen to call this Part A and Part B. I called it A because this sort of came first, this sort of came second. You can call them parts. There's nothing wrong with calling individual pieces parts. You can call them pieces. We also call them components a lot. Especially if the components are designed to be put together. But parts, pieces, components, they're all the same. What we do is we get an individual environment that accepts all of the output from all of these individual systems, and then we have to supply the entire system with all the ingredients that it needs to produce what it's producing. So what we get when we're done, we get this little tiny chain. Here's this word I'm going to use, chain of parts, components. Chain is used often. We really are talking about a physical chain with links in the chain. We talk about a chain as only as strong as its weakest link. That's a phrase that we use a lot. We use a lot of chains in our society. More recently, we have a technical term called a blockchain, and we're going to be talking about blockchains in higher level ISBIT classes. But in our lab for this class, we did the beer distribution game. We were specifically talking about a supply chain. And what was happening is that we were talking about Part A, supplying the inputs needed for Part B, so that Part B can eventually produce its output. So we're going to be talking about the individual parts. They can be called components. They're systems themselves, and together they're all chained together. And if you break the chain, then you don't get the ultimate output. And again, back to the phrase, the weakest link of the chain is the weakest link. It happens to be the weakest part of the entire chain.